In this segment, we will look at the properties of trigonometric ratios. In this segment, we have a set of objectives that we will aim to achieve. The first is that we will label the sides of a right triangle in relation to a given angle and identify the trigonometric ratios that should be used to find the length of those sides. We will be able to label the sides of a right triangle in relation to a given angle and identify the trigonometric ratios used to find the missing sides. And also we're going to label a right triangle in relation to a given angle, identify the trigonometric ratio, and find missing sides and unknown angles by using the trigonometric ratios. So let's go ahead and summarize. So the hypotenuse is the longest side of the right triangle. It is the side which is opposite to the right angle. Here our angle in question is theta, and it is marked with that O with that striking mark through it, and that is our angle. So our opposite side is opposite to that angle, marked here in blue. That's called our opposite side. And then our adjacent side is on the same side of the angle. It's that side that is closest to the angle. After you would have identified the hypotenuse and the opposite, then it's easier to be able to identify the adjacent side. Alright, so now it is very important to be able to identify all these sides, the hypotenuse, the opposite, and the adjacent sides, regardless of the orientation of our right triangles. So we're going to look at these 8 questions and identify our sides based on the marked angle that we have. And of course, as you can see, these triangles are in different orientations. Alright, so for question 1, we see that our marked angle is x degrees. Our triangle is labeled X, Y, and Z. And so we're going to identify our sides using the first letter of the name of the side. So our opposite side, we would identify that as O. Our hypotenuse, we're identifying that using the letter H. And our adjacent side, we're identifying that using the letter A. Alright, so in question 1, we see that our marked angle is X. Now our marked angle is not our right angle. We have 2 angles that are marked there. We have the right angle, which is indicating where our right angle is, and we have our marked angle, which is in this case angle X degrees. All right, so the first side we're going to identify is our hypotenuse, and our hypotenuse is the side that is opposite to the right angle, and we see that side being labeled as H. And then we're going to find the opposite side, which is opposite to angle X, and we're labeling that side O. And finally, the remaining side is our adjacent side. Alright, so we are going to answer 2 more questions for you to have the general idea at what we are referring to. So we're going to look at question number 2. Again, we identify our right angle. So we see where our right angle is, and it's that little square in the corner angle there. We know that that is our right angle. That is a symbol that we use to identify a right angle. So the first thing we're going to do is to identify our right angle. We identify our right angle. Opposite to the right angle is our hypotenuse. So now that we know our hypotenuse, we have 2 other sides to identify. So the next side we're going to identify is our opposite side, and the opposite side is opposite to the angle that we are referring to. And in this case, the angle that we are referring to is angle X. And angle X, the side that is opposite to angle X, is opposite side. And we use O to mark that angle, and therefore our third side, of course, is our adjacent side. We are going to turn our attention to question number 7. Again, I'm looking at, in this particular case, I'm looking at orientations that are a little bit out of the norm that is easy for you to miss. Alright, so the others are straightforward because the shapes are relatively upright and it's easier to identify. So I'm going to zoom in now on question 7. Again, we start by identifying our right angle, and in this case our right angle is at angle F, and so the side that is opposite to that angle is our hypotenuse, and so we label that side H. So our angle in question is angle X degrees, and so the next side we are going to identify is our opposite side, and our opposite side is opposite to angle X. So now that we know that our side is opposite to angle X, we look across from angle X and there is our opposite side, and we go ahead and label that side O. And then we only have 3 sides in a triangle, so the remaining side, of course, is our adjacent side. Of course, you can use other approaches to identify the sides if you wish. So you could, of course, say that the adjacent side is the side that's closest to the angle. Go ahead, identify that first. Then identify your hypotenuse, because that's the easiest one to identify once you've identified your right angle. And then you can go in and fill in angle O. So use your strategies, but test them to ensure that the definitions that you have are accurate and will allow you to accurately label the sides. So for a right angle triangle, the relationship between lengths and sides are described using the trigonometric ratios, and the 3 primary ratios are sine, cosine, and tangent, and we have shortened versions of each of these. So for sine, we use a shortened version, sin, which we still pronounce as sine. For the cosine, we have a shortened version, which we pronounce cos, cos. And for the tangent, we have a shortened version, which we pronounce as tan, tan. All right. Now, each of these ratios is in relation to an angle. All right. So we will see here, for example, sine A, where A is an angle, which is an argument that the sine function accepts. So we read this as the sine of angle A is a ratio of the opposite side and the hypotenuse. The cosine of angle A is a ratio of the adjacent side and the hypotenuse, and the tangent of angle A is a ratio of the opposite side and the adjacent side. Of course, we have different representations, and the angle names will change based on the angles that we're referring to, and we can shorten this version even shorter by using OPP for opposite and HYP for hypotenuse. And in this case, on your right, we're speaking in relation to angle alpha. So the sine of angle alpha is the ratio of the opposite side and the hypotenuse. The cosine of angle alpha is the ratio of the adjacent side and the hypotenuse. And the tangent of angle alpha is the ratio of the opposite side and the adjacent side. Now, all of these calculations will have to be done using your scientific calculator. And depending on your scientific calculator, there are 2 approaches that can be used when we want to input a value into the sine function or the cosine function or the tangent function. In one instance, we will press the sine button, SIN, the sine button on our calculator first. Then we input the size of the angle that we're referring to, which in this case is 30 degrees. You wouldn't put degrees, just the 30 representing the angle, and then you press the equal sign or the output button, and it gives you the value of the sine of that angle. Also, in some calculators, you will have to input the value of the angle first, followed by the sine function, and then the output button or the equal button. As with many other things, when you're studying, it is a good idea to have some kind of acronym or something that will jolt your memory to remind you of certain principles and concepts. And remembering the trigonometric ratios is no different. In this case, we have presented an acronym that can be used to remind you of the ratios, and it is Sokkatoa. Try not to spell it logically. It's Sohcahtoa. Alright, and the S stands for sine, and the O is opposite, and the H hypotenuse. So it's a sine ratio opposite over hypotenuse. C is for cosine, A adjacent, H hypotenuse. So the cosine ratio is adjacent over hypotenuse. And T is for tan, O is opposite, and A is adjacent. So the tan ratio, of course, is opposite divided by adjacent. And again, all of these are in relation to the sides of the right triangle. Again, we have these triangular formations where we can look at these triangles, and we have the sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. All right, so again, these are mechanisms that can be used to help you to remember these ratios, which is going to be critical as we progress into further information. Now, in any given question, we will have to decide which ratio is best applicable or most applicable to the question that we are answering. And so it is very important that we use a process of elimination to be able to identify which ratio would be most suited to the question. So if we look at this diagram, we see that our angle in question measures 35 degrees. We're given the length of a side as 12 centimeters, and we are required to find the length of the side marked X. Now, before we could go in and find the length of the side marked X, we need to decide, based on the angle which we are given, which ratio would be most suited to be used to find the length of side X. In this case, we must identify which ratio we're going to use. All right, so first of all, we identify the hypotenuse, and we do that by identifying the right angle. So we identify the right angle, so we mark our hypotenuse H. In relation to the angle that we have, we see that the side opposite to the angle which is marked X is our opposite side, so we label that O. And of course, our remaining side is our adjacent side, which we have a value of, which is 12 centimeters. Now, in relation to our angle, we are given the adjacent side, and we wish to find the opposite side. So we must look to see which ratio ties opposite along with adjacent. All right, so let's go through. Sine is opposite with hypotenuse. Is that the one we need? No. Cosine ties opposite. Cosine ties adjacent with hypotenuse. Is that the one that we need? No. Tangent ties opposite with adjacent. Again, we are given the adjacent side here, and we wish to find the length of the opposite side. So of course, our ratio that we're going to use to answer this question is going to be our tan ratio. Look at another example. So in this case, we're looking at our angle under consideration is 35 degrees. We see that we have a side marked X. We also see that we have another side marked 12 centimeters. So let's go ahead and label our sides according to whether they are opposite, hypotenuse, or adjacent. In this case, we identify our right angle. So the side opposite to our right angle is our hypotenuse. So we go ahead and label that side H. In relation to our angle, the side that we can see on the opposite side of the angle is our opposite side. So we go ahead and label that O. And of course, the remaining side in our triangle is our adjacent side. Now, in relation to having all our labels in place, we need now to identify which ratio we are going to use. Now, we are finding the side marked X. which we identified as the adjacent side, and we're given the side marked 12 centimeters, which we identified as our hypotenuse. So we need to identify which ratio ties adjacent with hypotenuse. Is it the sine ratio that ties opposite and hypotenuse? Is it the cosine ratio that ties adjacent and hypotenuse? Or is it the tan ratio that ties opposite and adjacent? What do you say? I agree. It is the cosine ratio that ties adjacent with hypotenuse. So cos of angle 35 degrees will be equal to x divided by 12 centimeters. And let's look at a final one. So again, we have our angle is marked x this time around. We have a side that is marked 5 centimeters. We have a side that is marked 12 centimeters. We have a side that is not labeled. Let's go ahead and identify which ratio we would use to find the size of angle marked x. Now, in relation to the marked angle, we identify that the side marked 5 centimeters is the opposite side. In relation to the 90-degree angle, we recognize that the side marked 12 centimeters is our hypotenuse. So therefore, we need a ratio that ties opposite and hypotenuse. What are you thinking? Is it the sine ratio that ties opposite and hypotenuse? Or is it the cosine ratio that ties adjacent and hypotenuse? What about the tan ratio that ties opposite and adjacent? Did you say the sine ratio? Why? Because it ties opposite and hypotenuse? Good job. You really got it on the third try as well. Alright, so that is the ratio that we're going to be using. The sine ratio that ties opposite with hypotenuse. So therefore, sine x is equal to 5 centimeters divided by 12 centimeters. So here's a tip before we move on. Have you noticed that we used the trigonometric ratios with right triangle problems only? You should have. In addition to that, we can use the trig ratios, which we say for short, to find either the length of a side in a right triangle or the size of an angle. Here's a checkpoint question for you. What is the difference between using Pythagoras' theorem to solve questions relating to right triangles or using the trigonometric ratios to solve problems relating to right triangles? Think about it. In right triangles, Pythagoras' theorem is used only to find the length of a side, while the trigonometric ratios can be used to either find the length of a side or the size of an angle. Good job. Here are some key points to note.